Hello, students. It's Mrs. Cinti here, and today we are going to talk about comparing and ordering rational numbers. Um, and so, a good example of why this would happen is we've been watching figure skating lately at my house, and um, let's say that an ice skating competition, couple A, this couple here scored 6 and 5/16, so that was their score. And couple B, the one that came on after this, scored 6 and 7/20. So the crowd is sitting there like, what? Who won? Who won? Right? Which one's bigger? When you compare the two integers, okay, so kind of the first step here would be to compare the two integers, meaning is 6 greater or less than or equal to 6? It's equal to, right? So you can't really compare these. You have to ignore this. So now it's just comparing these two fractions. And so how do we compare two fractions? And so that's what we're talking about today, okay? So let's go ahead and look at this one example. So if you're comparing your fractions, you have the 5/16, and so is this greater than, less than, or equal to 7/20 is your deal, okay? So what we're going to do is we're going to turn these into equivalent fractions, which you are familiar with, by finding the least common denominator. Okay, so if you look at 16 and 20, okay, and you kind of move up to multiples of 16, and multiples of 20. Okay, you would do 16, 32, 48, 64, and 80. Oh, 80 looks pretty good as far as 20 goes. So 20, 40, 60, and as you know, 80. So this is your lowest common denominator right there, your least common denominator. So what did we do? We multiplied 20 times 4, so it was 20 times 4, and we multiplied 16 times 1, 2, 3, 4, 5. Okay, so that means to change the fractions themselves, we need to go back to 5/16 to get them to be equivalent. We multiply these by 5, and we would get 25/80. And then the 7/20, we had to multiply it by 4, so we multiply both of these by 4. And we get this to be 28/80. Okay, so which fraction is bigger, 25/80 or 28/80? And we clearly have found our larger fraction, meaning that the couple number 2, 1, and the way that you would write that is you would rewrite it as 6 and 5/16 is less than 6 and 7/20. Greater number, okay, and couple 2, 1. So that's one way to go about this, by comparing two fractions. They're very similar numbers, but they just have two different denominators. So let's look at another example. The density property is another thing that we want to kind of keep in mind. It says that an infinite number of rational numbers can be found between two rational numbers. So what this means basically is between 5 and 10. You know, there are numbers there, right? There's 6, there's 7, there's 8. There's even like 9.5, 9.51, 9.52. So between 6 and 7, there is 6.1, 6.2, 6.3, but then you can get into the hundredths place, the thousandths place. You can go infinitely to the right of the decimal. So that's kind of that infinite number. So when you have between these two, you're saying what comes between 10 and 3/5 and 10 and 4/5? What fits here? What are some of those infinite numbers that come between them? How can we figure those out? Okay, so how we do that is we increase the fractions given, right? So in this case, the 3/5 and the 4/5. two greater equivalent fractions. So yes, they are kind of equivalent right now as far as their denominators, but let's expand them a little. So if we were to, just for instance, multiply 3/5, if we were to increase it by 2 and 4/5, increase both of them by 2, we would still have equivalent fractions, 10 as their denominator, and then 10 and 8. So what's a number that fits between 6/10? So this is kind of the same as saying what comes between 10 and 6/10, and what number comes between 10 and 8/10. And here we would be able to very clearly say that 10 and 7/10 is a number that comes between this. Okay, so that's a way to to show that the density property is still true even when you feel like you've hit a roadblock, because these are both the same. Okay. Other kind of comparisons that you might be asked to do in this section and with fractions just in life is comparing a fraction and a decimal. Okay, so how do we compare other combinations of fractions and decimals? One big thing that you can do is just turn your, it's hard to turn a decimal into a fraction, but it's fairly straightforward to compare, to turn a fraction into a decimal. And so what we would do is we would do a, 7 divided by 2, and please don't forget that negative. So it's still going to be negative. So you're comparing negative to negatives. And does 7 go into 2? No, it doesn't. We have a decimal here. We move the decimal up here, and then we put on our 0. Does 7 go into 20? Yes, it does. It goes in 2 times 14, 6. We bring a 0 down. Does 7 go into 60? Yes, it does. It goes in just about 8 times to give us a lovely 56. And then we go 40. We get another 0 down here. Does 7 go into 40? Yes, it does. Perhaps 5 times. But at this point, right here we could have stopped because we're comparing 4/10, negative 4/10, to negative 2/10. Which one is bigger, right? This one is very clearly bigger, okay? Almost twice as big. So this is a way to compare those two things, is to turn that fraction just right into a decimal, and then you don't have to take it any further. The comparison is which one's bigger, and you've proved it by that very first decimal. Okay. So what's another type of question that you could be asked to do? Compare fractions by multiplying. This is pretty cool. So if you have two fractions and you're trying to figure out which one's bigger, and let's say you have 7/12, you don't know, and then you have 3/5, okay? There is a little trick that you guys can, that I'm going to let you in on. What we can do is we can actually, if you draw a line and you say 5 times 7 is 35, and make sure that arrow goes to the top because you're going to be talking about that side. And then 12 times 3 is 36. Which number is bigger, 35 or 36? 36 is, so that means that 3/5 is your bigger value. How cool is that? Okay, how cool is that? I just think that's the coolest thing ever. So let's try another example. Negative 6 over 11 versus negative 5 over 9. So what is it, right? Well, that's the big one. And then 9 times a negative 6 is a lovely negative 54. 11 times negative 5 is negative 55. And so again, the right side is just coincidental. But the right side is, no. The right side, we're dealing with negatives. Gosh, thank goodness I looked at my notes there. We're dealing with negatives. So negative 54 is actually a larger number than negative 55. Sorry about that. Right, because on the number line, here's 0. Here's negative 55. Here's negative 54. Right, so this is a larger number. Whew, thank goodness we caught that. And so the last thing that you need to know in your notes is, how do we compare mixed fractions and improper fractions? So for example, if you have a mixed fraction of 2 3/5, and you have an improper fraction of 15/7, okay, you can compare these in two ways, and the two ways are really just converting one into another or the other into the other. So if you have a mixed fraction and you feel more comfortable turning that into an improper fraction, then you would compare those two numbers. So, so let's go ahead and turn 2 3/5 into an improper fraction. Okay, and what we do is, in case you've forgotten, which is fine, you multiply 2 times 5, and then you add 3. So 2 times 5 is 10 plus 3, so this is actually 13/5. Okay. And so the question that you're really being asked is 13/5 greater than or less than 15/7? So not super helpful, right? Because now we have two different denominators. We're comparing like apples and oranges right now. So then you would go back to your common denominator idea and maybe just multiply 13. It may be easier to just do multiply this by 7, multiply this by 7, multiply this by 5, multiply this by 5, and then you get 75 over 35. I did this math earlier. You may have to do it on the side. And you would get 91 over 35. And so then you compare these two, and clearly 95 over 35, which is really 13/5, is larger. And so that's why you know that there's that greater sign there. Okay, so that was the first way, turning the mixed fraction into an improper fraction. But you could also do change an improper fraction, oops, that's 7, to a mixed fraction, and kind of go through the same idea. And the way that you do that is you do 7 into 15. How many times does it go in? 2, 14. You have a remainder of 1, and so what that really means is that you have the 1/7. So 15 over 7 is really 2 1/7. And so the question is 2, and the original problem, 3/5, greater than, equal to, or less than 2 1/7. Again, we're comparing two numbers with different denominators. So we can again go to the 3/5 times 7 times 7. We get 35 over 21. And then with the 1/7, we would multiply by 5 to get that least common denominator. We get 5 and we get 35. So which one of these is smaller, or which one of these is larger? This one is larger, which means that the 3/5 was larger because you compared 2 and 2, and that was not. And so then that is your answer, which actually agrees with this side, which is perfect.